So today we're going to be using the elimination method again. So it's still the same method as yesterday, but we're going to talk about what happens if the variables don't cancel out exactly. So let's look at the first problem here. You see 4x plus 3y equals 2 and 5x plus 3y equals negative 2. First of all, my variables line up. X's are on top of x's, constants are on top of the constants. But what you should notice is that those y's won't cancel out. In order for the y's to cancel, one has to be positive and one has to be negative. So what you actually do in step 1 is you're going to multiply one entire equation, doesn't matter which one, I typically choose the bottom one. I'm going to multiply one entire equation through by a negative 1. So each piece gets the negative 1, distributing. That's going to give me negative 5x plus negative 3y equaling positive 2. Negative 1 times negative 2 is positive 2. So now what you do in step 2 is you take the equation I haven't used yet, so the 4x, put that on top where it belongs, 4x plus 3y equals 2. The new equation comes down to the bottom, negative 5x plus negative 3y equals 2. And now you'll notice that my y's will cancel out. Still adding. From here on out, it's exactly the same as yesterday. 4x plus negative 5x is negative 1x, and 2 plus 2 is 4. I'm going to divide each side by a negative 1, and I get x equaling negative 4 for the first part of my answer. For step 3, you need to plug back into one of the two original equations. Doesn't matter which one you plug back into. I typically prefer ones without negatives, so I'm going to plug into the 4x plus 3y. So 4x plus 3y equals 2. 4 times 4 plus 3y equals 2. 16 plus 3y equals 2. Add negative 16 to each side. I get 3y. Oh, my 4 should be negative, so that should be negative 16, adding 16 to each side, and I get 3y equaling 18. Divide each side by 3, and I get y equaling 6. Sometimes those negatives can get away from the best of us. So now we have x equaling 4, and we have y equaling 6. Final answer is an ordered pair, written as negative 4, 6. Last step, like always, check into the original equations. So the first equation that I'm going to check back into is 4x plus 3y equaling 2. 4 times negative 4 plus 3 times 6 needs to give me 2. Negative 16 plus positive 18 needs to give me positive 2. Positive 2 will give me positive 2, and my answer checks. Checking it in the second equation. 5x plus 3y equals negative 2. 5 times negative 4 plus 3 times 6 needs to give me negative 2. Negative 20 plus positive 18 needs to give me negative 2. Negative 2 gives me negative 2, and my answer checks. Looking at the second problem, this one would be on the back of your graphic organizer. You'll notice in this one that my variables aren't lined up. I have a 5y underneath a 2x, and I got to get everything to match. In order to get all my variables to line up, I need to do some work with this second problem with the 5y. I need to move the x to the other side. I'm hoping you remember that to move an x to the other side, you just add negative 4x to each side. So here's what I have now, because I know that's kind of hard to read. I have the 2x plus 5y equaling 12. I brought over a negative 4x plus the 5y from the original problem, and now that 6 is over there by itself. So now my variables line up. You might also notice that the 5y's are pretty close to canceling, but not quite. They're both positive. I need to make one of them negative. So pick one of the equations. Again, I typically choose the bottom one, and I'm going to multiply everything in that equation through by a -1. So again, the distributive properties. Positive 4x plus negative 5y equals -6. I'm now going to use this new equation plus my top equation, and I'm going to line them up on top of one another. So now that I have my two equations, I'm going to go ahead and line them up on top of one another. So I have 2x plus 5y equaling 12, and I'm going to end up with positive 4x plus negative 5y equaling -6. The 5y's cancel each other out, and I add. 2 plus 4 is 6x. 12 plus -6 is positive 6. Divide each side by 6 to get x by itself, and I get x equaling 1. I need to plug into one of the two original equations to find my missing variable. Doesn't matter which one you pick. Just so you can see it, I'm going to pick the 5y equals 4x plus 6. Everywhere I see x, I'm plugging in 1. So 5y equals 4 times 1 plus 6. 5y equals 4 plus 6. 5y equals 10. Divide by 5, divide by 5, and you get y equaling 2. Ordered pair, 1, 2 as your final answer. Checking this one, again, back into the original equations. So 2x plus 5y equals 12. So 2 times 1 plus 5 times 2 needs to give me 12. 2 plus 10 needs to give me 12. 12 equals 12. And my answer checks. 5y equals 4x plus 6 as my second equation. 5 times 2 equals 4 times 1 plus 6. 10 equals 4 plus 6. 4 plus 6 does in fact give me 10, and my answer checks. So very similar to what we did yesterday. It's just that you have to multiply one of the equations, everything in that equation, through by a -1 first.